Okay, so we're doing a little bit of practice problem. In fact, I better show you what it looked like in the first place. There we go. There's my original function, and now we are finding this. We absolute valued the x's, and if I were you at home, I would stop right now and do these three problems. One of them in blue, one in green, and one in red. And I would make separate axes for them so that you don't get them all in one graph. It'll just be really messy. All right, so the absolute valuing the x's part, you get rid of this, and then this part, I'll do it in blue, will contain the original one here, but then reflects that, and that is awful. I have no artistic ability sometimes. Okay, I'm gonna try again. I'm trying to make it so there's a line of symmetry right down the middle here. I think that's good enough anyways. Raise your hand if you had something like that. Okay. Now, remember it was lawn chair function. Something like that. What do I do for the green one? Can you do it, sir?
Sure. You take the values in negative y.
The negative y values, which would be this part and this part, and then do what?
And then you flip them over and invert them.
Yep, you got it. And then that with the blue is your final answer. These had to go away. Raise your hand if you had that one right. Cool. And then the last kind. Lawn chair function except 1 over it. Well, here's our lawn chair again. And what are the key moments? Well, there's two big things I want you to remember. The asymptotes, which are where you take the zeros and you put an asymptote through them. And then you take the spots where it's 1. Now, how am I supposed to know where it's 1? I would have to tell you that. Because if I don't tell you where 1 is, the graph will look totally different. Okay, so I get how you would not be able to have finished this at this point. I will tell you that this is 1, and that this is 1, and let's say that it touches 1 down there. I know those are off a smidge. I'll move them. This down a little bit. 1 and 1. And why are the ones and the negative ones so important? Do you remember why, Miss Pat?
Because those are the only points that are going to stay the same.
Yes, those are the only points that are going to stay the same. Now with those dots and the asymptotes, you need to be able to connect the dots. Well, what are the rules on that? You never go across the asymptotes. You always get closer and closer to the asymptotes. And you never cross the x-axis. Okay, now the never cross the x-axis part, just don't think of the x-axis as an asymptote. That's different. Just don't go across the x-axis. I know there's one example where you can, but let's not even worry about that because that's really rare. Down through here, up there, and then, oh, I never identified this spot as being 1. It would logically follow. Down like that, and I'm going to on purpose make a mistake here. And this, and I could see a kid just doing that, and I'd have to cry a little bit and mark it wrong because there's 2 things they did wrong. Can you name one of them, Robbie?
It doesn't keep going.
Yeah. This lawn chair does not have an arrow at the top of it. It is a dot. And if you ever want to ask on the test, like, does this keep going or not? Ask. Because if it stops, then your graph needs to stop. Right underneath it. Straight underneath it. Because why? Because the x values don't change. It's only the y values that are 1 over what they used to be. And if you really wanted to know for sure what that was, you could say, well, I'm going to say that this is about 12 comma 10. And then you'd say 12 comma 1 over 10, 1/10. And yeah, that's really low here. So it's actually logical that there'd be a point straight underneath it. Same x value. Okay, and the other thing is, this is small, but look at that. I never accounted for that part. That part of the lawn chair that was underneath the x-axis. So let's just say, to keep our life simple, that that touched 1 right there. If that touched 1 right there, then that point would stay the same, and my graph would go like this. closer and closer to the asymptote. What if that point didn't touch 1? Well, in a way, it's simpler. Tell me what you think it is if it's not 1. Let's say that it's negative 8 comma negative 3/4. If it had been negative 8 comma not negative 1, negative 3/4. Well then, I would simply be able to take this, and what's 1 over a fraction do? Flips it. So this become negative 8 comma negative 4/3. And that's negative 1 1/3. And I would start there and then get closer and closer to the asymptote. Either way, I'm going to have a point there that gets, and it goes closer and closer to the asymptote. All right, I know those can be confusing, but I think there's so many things to learn. I think we have to move on to other things. Here's another topic. I give you a point 2 comma 10, and I tell you is on f of x. 2 comma 10 is on f of x. Great. What do I do with that? Nothing yet. But what if I say blank comma blank is on the same function except it's been mutated a bit. For f of 2x minus 5 minus 10. So basically, we had a function. We did a bunch of stretches and moves and flips and stuff to it. Now, where's that point? Pause for a minute and let you compare with a partner. So let's see how you did. Here's how I would have done it. I would have thought, okay, this is my x, and that goes with this stuff. And warning, really common for kids to go, well, I'll just stick it in for x then. Nope. You don't want to put it in there. You want to say 2 is equal to 2x minus 5. That way you will do the opposite things to it. You'll add 5, and instead of timesing by 2 here, you'll end up dividing by 2. Final answer, 7 halves, 3.5. Raise your hand if you had that one right. Okay. If you didn't, do you have any questions for me about what I just did there? All right, then let's do the y value. Would you agree that this 10 is the y value? Now, I hope you know that all of that f of x, that right there is f of x. And f of x is the y value. So that's where I can put the 10. And do I trust this and just do times 4 and subtract 10? Yeah, it's on the outside. You can trust it. So 40 minus 10 is 30. So you got 30. And the other one was 3.5. 3.5 comma 30. Raise your hand if you had it both right. Okay, cool. Any questions on that? All right. Then, what else do you have to know? Why don't you pick a topic? I've taught you a lot of things this chapter. What haven't I talked about lately? Maybe you could be something where there could be something where you want to know how to do a certain kind of problem. Or can you even think of any that I haven't practiced today? Pat.
I was looking at the review sheet, and you had G inverse F of X, or like G to the negative 1 power.
All right.
X.
It is good to remember what this is versus what we've been doing lately. What we've been doing lately are those reciprocals. That's where you get the asymptotes and stuff. Do you still have to know last chapter's stuff? Yes. So if I gave you this function, g of x is equal to 4x minus 7, do you still remember how to find an inverse?
Oh, yeah, sorry.
It's all right.
I only have mental capacity for one thing.
One chapter at a time. So then you go x equals 4y minus 7, and then you solve it. Does that ring a bell?
Yeah.
All right. So that's different than the 1 over f of x problems we've been doing lately. But you do still have to know last chapter stuff. Okay. I'll just finish that off, and it'd be x plus 7 equals 4y, and divide both sides by 4. I'll separately divide them by 4 this time, and I'd get y equals x over 4 plus 7 over 4. And there would be my inverse. That's this. And if we were doing last chapter, I would have said, and what's the domain and range of it? Which would have come from the domain and range of the original. And since the original's domain and range was all reals in both directions, because it's a straight line, then this one would have to have domain and range of all reals in both directions. Okay, good enough on that. So, there was a whole day at the beginning, and we actually had the first day of this, like right before conferences week and all that, where I would give you a picture like this, and then say, where is it increasing and decreasing, and where's the local maximum and the local minimum and all that stuff. Let's do one like that. Let's say this is 5, 2. Let's say this is -1, 4. I think that's all you'd really need. Can you tell me local min, local max? Give me more questions.
Even or odd?
Ooh, yes, except we should talk about that, but not right this second. This is not one that's good for like testing, proving whether it's even or odd. I could look at it and say it's not even and it's not odd. But let's remind me of that later in the hour. I should go over one review of that. Okay. So, local min. Put 5, 2. The low spot. That's it. Local max. Did you put -1, 4? Okay, good. What is another question we could answer about this? Yes? Abs max. What is it? Daniel, you know it?
There isn't one.
You are correct. There's no absolute max. How about abs min?
There isn't one.
There is not an absolute min because it keeps going down. You may not say negative infinity because that's not a place. Okay, what else could we ask? Yes?
Where it increases and decreases.
Yes, everybody write down the increasing interval or intervals. Velour, can you tell me an increasing interval?
-30 to -1.
And why'd you choose the -1 instead of the -4?
Because you go by x values.
Very good. And what's the other one?
5 infinity.
You got it. I'm seeing a couple cell phones out. If you could put those away, you're not using them. Otherwise, I'd be mad. But if you have a cell phone out, put it away. All right, decreasing. Senna, what do you say for decreasing interval? You are correct. -1 to 5. Okay. Any other question that could be asked about this? Yup.
The zeros?
The zeros, very good. I never actually named them though, but what is a zero? It's the same thing as, well, there's actually 4 names for them. Zeros are the same as x-intercepts, which are the same as, starts with an R, the roots, which is the same as the solutions. And that's this spot right here. That's the x-intercept, the zeros, the roots, and the solutions. 4 names. If there's 4 names for something, increases the chances you get asked questions about it, right? Because they could ask you the root, or the zero, or the x-intercept, or the solution, and all of them be the same thing. Okay, and then the last one I'll throw out there is range. We typically will ask a range of a function like this, but this is a pretty easy one because it keeps going in both directions. So you could say it's negative infinity to positive infinity. All right, now we just did a bunch with these functions that I was having you like put the absolute value in it somewhere. What if we did this? You know what that looks like? Then do you know what that looks like? Don't try to do it all at once. First, figure out what it looks like before I put in those absolute values. And then try to figure out what it looks like after you put in the absolute values. Now pause for a second while I give this a shot. Okay, here's what I would have hoped would have happened. You'd go, okay, without the absolute values, it's just a square root that's been shifted to the right. If you started right, raise your hand. Okay, good. Now, when this absolute value goes on the inside, I know some of you are thinking, but there's nothing on the left. So what do? I guess it doesn't change. No, that's not the case. When there's something that gets absolute values on its x's, there's two parts. One is to erase anything that was there, but the other is to reflect it over so that there's a line of symmetry running down the middle. Raise your hand if you had both of those up there. Sweet. Okay. So, I know some of you are probably thinking, yeah, I'm good. I'll be fine tomorrow. I strongly recommend doing some practice problems. It's never easy to have a test after you've had 2 days to kind of forget everything. So I do want to do a review of the even, odd, neither. Just looking at this, does this look like even or odd or neither? Say it if you know it.
Even.
Even is correct. Okay, and how could I prove something's even or odd? Just tell me the rules. It starts with f of negative x. Do you remember the rest of the rule for even? Do you remember the rest of the rule for odd? Just hold on to them for a second. Everybody write them down if you know them. And if you don't know them, even more reason to write it down. Just wait a second, I'll tell you. Crocker, what do you think the even rule is? Yep. And if that happens, you stick in negative x and you get the original function back again, then you got an even one. How about the other one? It's very similar. Zodi, can you tell me the other one?
Odd is f of negative x equals negative f of x.
You got it. And I'm going to just put a negative 1. Just to remind you, on this kind, it's smart to factor out a negative 1. Do you get, I don't have to have the 1 there, but I'm reminding you that if you were doing an odd one, you'd want to factor a negative 1 out at some point near the end of the problem. Okay. All right, so where do you get some problems to practice? Well, if you haven't already, there's a quiz that's got an answer key. Strongly recommend doing that. That already should be done, but if you haven't done it, that'd be a top priority because you got an answer key for it. The other part is some practice problems that doesn't have an answer key. I'm going to try to find that, but I cannot promise you that I'll be able to post that. I don't have the time to be able to make up a whole key and post it, but if I can find the key, if it's already made, I will happily find it and post it. That's usually about 85% of the time I can do that. Okay, any last questions? All right, so at this point, is there anything that is in the reviews, anything that you're worried about? Like, we have time, I can do a repeat of one of the kinds of questions, like, I don't get the kind where you absolute value the inside, or I don't know, whatever. Anything you want to ask? Yes?
Are you asking if we want like an example problem?
Sure, please.
Okay, well, for the even and odd maybe?
You want to do one of those?
Yeah.
All right. So let's do x squared minus 3x. I feel like it should be even because it's got a squared in it. But prove if this is either even or it's not even. Toby, do you know what the first step is?
Yeah, you replace the x with negative.
So f of negative x equals negative x squared. And I on purpose just made a mistake there. and it would be a critical one. What did I just do wrong, Toby?
You're supposed to put the x in parentheses.
And why will it matter? Because of the squared. Because without those parentheses, the answer should come out negative, and with the parentheses, it should come out positive. So that's why it's so critical that an x be replaced by a parenthesis. Okay, and then you'd have this. And then you're either going to have the big finish of f of negative x is equal to f of x, or it's not equal to f of x. Is this actually f of x? No, so then I say not equal to, and therefore not even. We just proved that it is not even for sure. What if I'd have wanted to prove it was odd? At that moment, I would have factored
A 1.
a negative 1. If you'd have factored a negative 1 out and then you got the original function back, you wouldn't have. But if you had, then it would have been odd. And then if you go through both of those and you've proven it's not even and it's not odd, it's just called a neither. All right, we will do one more of those tomorrow because I didn't talk about that in my other classes. So, all right. That's all I got for you for the video for today.